I'm Alison Crocker. I'm a professor in the physics department. My research is in astrophysics. So I study the physics of how young stars are born in other galaxies. But engineering-wise, I've advised and mentored several students who've gone on to engineering, a few through the 3-2 program and a few through just other pathways, some of which we'll get to in a little bit. And then my sister is also a power systems engineer, so she studies our electrical grid.
My name's Eli Eastman. I graduated from the Reed Physics program last year. And I was very interested in studying engineering for a while and strongly considered following the 3-2 program path and ultimately decided not to. Right now, I'm working for a semiconductor company in Portland, but in the summer, I'm going to be starting my PhD in applied physics at Northwestern.
My name's John Essick, and I'm a professor in the physics department along with Alison. And this year and the last several years, I've been the chair of the dual degree committee, which is the pathway that people follow for the 3-2 to go on to the other sister schools that we're allied with. And personally, I have 3 children, and 2 of them have done 3-2 programs at other schools than Reed, and now are engineers.
My name is Ribby. I graduated Reed at 2018. I was actually one of John's thesis students, and now I'm third year in mechanical and aerospace engineering at UCI PhD program.
Well, again, so glad to have you all here. Now, for this, I've asked John just to start off by talking a little bit about the 3-2 program, because I know a lot of you are curious about this. You hear about this at liberal arts schools. And then we're going to move more so into how faculty are working with students to help them make their decisions from, where they are here all the way up to where Ribby is right now.
Engineering's a very expensive undertaking for a university, and so small liberal arts colleges really can't afford to cover the many sub-disciplines of engineering and get all the equipment and hire the expensive professors. And so Reed, along with many other liberal arts colleges, has a 3-2 option where you can come to Reed and get the liberal arts experience for 3 years. And then you transfer to, we have 3 options of schools to go to. Our most popular ones with Columbia University. And then we have an agreement with Caltech and also Rensselaer Polytechnic Institute in Troy, New York.
Alison, can you share with us the type of conversation that a student who's they come here, they say, let's do 3-2. What is that first conversation like? How do you help them think about this?
So the first conversation actually becomes pretty involved pretty quickly, because if you even want it as an option on your table, you do have to plan from the very beginning, because to fit the coursework you need in for the 3-2 programs, you do have to think starting from day one and just to plan it out. And that's not to say that everything is so rigid that you get no choice, that you don't really have a liberal arts feel for things, because you do. Because part of the requirements are figuring out where the Reed requirements for graduation, the group requirements fit in. And that's going to be 6 courses that are truly, well, in addition to the first year humanities, 6 courses that are really truly outside of the courses that are required for sending you to 3-2. So you really will get that liberal arts experience as a 3-2 student, but you have to plan how it all fits together from day one. And so that is, the first conversation is an involved one, because you have to look at those full 3 years and plan out pretty much what's going to go where. But that's just the conversation to have to keep it as an open option, because as you'll hear, there are ways through engineering that are through the 3-2 program, and there are ways that aren't, right? Both of our students here are ones who are pursuing engineering type paths that didn't end up doing the 3-2 program. And so the first conversation also tries to make that very clear, that this isn't a decision. You want to plan things so that you could do the 3-2 program, if that ends up still being the thing you want to do sophomore year and then still in junior year when you actually really have to go for it. But there are also other ways that you could stay here for the full 4 years, do a Reed thesis, and then head towards engineering ways thereafter.
Alison, I loved how you described it, because I think that is not uncommon for students to come in and say, this is the path I'm planning on. And Eli, I'm glad you're here to talk about this. And sometimes they decide to do different things. But what I hear you saying is we make sure that option is available for them once they get to a decision point. And at that decision point, they make the call whether or not they're going to move forward or do something else.
On your admissions materials, you'll be asked what major you're interested in and things. If you really are interested in 3-2, definitely put that on there, because then usually you'll get assigned to me or somebody in the physics department who's familiar with the 3-2 program. And as Alison said, it's very packed on the requirements. And so you'll get probably the best advice from us. But if you do end up getting somebody else in a different major as your academic advisor, then just seek me out as the chair of the dual degree, and we can talk about your schedule.
When I entered Reed, I wanted to study computer science, and then I realized, well, maybe the things I'm interested in with computer science are more on the hardware side. So I thought I wanted to be an electrical engineer. So that's kind of the most, I think, traditional path to get into that field. And at the end of my freshman year, I started looking into options and preparing for the 3-2 program so that I was in the right courses and was ready to meet all the requirements at the end of my junior year. And it involved taking more physics courses than I was planning to my sophomore year. And I ended up liking physics quite a bit. And by my junior year, I was kind of like, you know what, I'm so close to finishing this degree and writing my thesis. And I really loved physics. And that just ended up, to me, being the best choice.
And you mentioned something that our families asked about, which is, if you do the 3-2, can you do a senior thesis?
Well, that's one of the reasons people end up not doing the 3-2. So it's unique to Reed because we have a required senior thesis, and the whole college sort of moves in that direction. And even first year students are thinking about what they want to do for their thesis a lot of times. And so when it comes to junior year, they realize I'm not going to be able to do a senior thesis, and they have all their friends telling them, why'd you come to Reed if you're not going to do a senior thesis? And so they end up deciding not to do it. And so I would say that's the number one reason why people who initially think they're going to do the 3-2 don't end up doing it. And when I'm talking to people who are interested in 3-2, I tell them, your friends are going to tell you, why are you doing this? And you just have to not listen to them. If you really want to do a career in engineering, you should do the 3-2. And so that's a big decision that people make in their junior year.
Ribby, can you talk a little bit about your choice and tell us a little bit about what you're doing these days?
I guess my journey towards engineering was near my fourth year, where you start applying to graduate schools. And I've been taking a lot of elective classes in physics, like thermodynamics and solid states, both of which John taught. So I was getting really into applied physics, and an extension of applied physics engineering. And actually my father graduated with an engineering degree, so that made me more motivated to try it out. And it's actually not, I don't think it's a hard journey to change majors, because one of the admission professors at UCI, I did take several classes with him, and I asked him later, I was curious why you admitted me into UCI. And he said, students with physics background, they have a very strong mathematical background. They're really quick to pick up on stuff. So the very first class I took, I didn't even know like the terms, but I picked them up pretty quickly. And it was hard at first, but it was just the first quarter that was hard. And then currently my research is I turn linkages into continuum and compliant mechanisms. So I try to reach the motion we have usually with joints through the bending of the mechanisms themselves.
I love the pride I see on your faces, Alison and John, when you're hearing Ribby talk about his story.
Very proud.
Thank you.
This past year, I've been working with a lot of engineers. I'm not working as one, but I I think you might be fighting just a little bit of an uphill battle because you're going to be there's all these people who go to college specifically for engineering and know all these kind of specialized kinds of math or different types of analysis or stuff, but I certainly have not had any trouble understanding those things or picking them up from my coworkers where I've needed to, and you will be perfectly capable entering a career in engineering, however you decide to do it after Reed.
So I have a few practical questions folks are asking, in particular about the 3-2 program. They're curious about admission into Columbia, admission into Caltech. Is it guaranteed? Is it assured? Do students have the option of getting into these programs? Do they get admitted?
So like I mentioned, Columbia is our most popular program. And in the past, about up to 5 years ago, there still is a whole list of classes that you have to take as an admission requirement to transfer into their program. And it used to be that if you met all the criteria laid out, which included a GPA as well as these classes you had to take, then you were guaranteed admission. And they changed that a few years ago. So now admission's not guaranteed. But I'll give you the example of this year. We had 3, they were physics majors, applied to Columbia, and all 3 did get accepted. It seems like if you do the criteria laid out, that you're pretty sure to get accepted. For Caltech, it's different. They give us officially very few guidelines on what you have to take to transfer there, but I've been told informally that they're only interested in students with a GPA of 3.8 or higher, which is Reed strives really hard not to have grade inflation, and so not that many Reed students have a 3.8 or higher. And so it's a little tougher, and they also draw from about 12 different schools. Reed's one of them, and they only accept 3 or 4 students from all of those schools. So Caltech's really hard program.
They've really tightened up in recent years.
They've very much tightened up, and it seems like they're not really supporting their 3-2 program that much anymore. In contrast to Columbia and RPI, who seem very welcoming to 3-2 students. And the students who go to those schools really like it.
Eli, so tell us a little bit about how you chose your path. You're heading looking for applied physics. How do you make that determination when you were thinking about so many different things?
I actually waited. So when I started my senior year, of course, I was thinking about applying to grad school, and I had done some research over the summer. But pretty much as soon as I started working on my thesis, I realized I could apply to grad school and write my thesis at the same time and do both of them just fine. Or I could write my thesis and do a great job and feel really confident about it and really happy with the work or time I was able to put into it, and then apply to grad school the next year. Mm-hmm. And that's kind of what I ended up deciding on. And of course, this was before we were all sent home and we had to stay inside and stuff like that. So I was thinking about this long before I had any idea of where we were going to be right now.
The world was going to change, right?
Right, exactly. I ended up being really happy with that decision because it gave me a lot of time to really think about what I wanted to do in grad school. And then there was the applied physics program at Northwestern, which really interested me because it was a chance to, one, there was a potential advisor who was essentially working on a direct continuation of my thesis. And two, it was a kind of a chance to take all of these physics I had learned and learn how I could use it to help research in other fields or to see how physics manifested itself in these other fields, and kind of scratch the engineering itch that I had been thinking about, since I was in high school.
What is the typical student experience for someone who's interested in engineering? How should they set up their path from when they first arrive at Reed if they just want to keep that option open?
The first thing is to look at the first year, and they'll be in Hume, right? This is like the cornerstone of Reed's first year, is an introduction to all the fields of humanities through this big intro course that covers now both classical and more modern times. So everyone's in that. It's a common shared thing. So everyone will be taking that. And then to start getting those requirements underway, doing probably math both semesters, depending a little bit on what level of math you enter in, and then also physics both semesters of the first year. And really to get the requirements in for the 3-2 program, you actually have to be taking also a 4th class both of those semesters. And what exactly that is a little flexible, but chemistry has to fit in somewhere along the way, and that's a perfectly good one to get in the intro year. And then other than that, to start thinking towards what you would like to take for your group requirements for maybe an art or language or history that's going to fulfill the 2 group requirements that really aren't fulfilled by getting the courses in for the 3-2 program.
What do they usually major in if they're going to do 3-2?
Almost all will major in physics, because for the engineering programs, there's so many of the requirements are in physics that to do it, the physics major is simply the most practical.
On the actual written requirements, all you have to do is fulfill the requirements for a Reed major up through the junior year. So it seems like you could be an art major, let's say. But when you look at what classes you have to take for the admission requirement, let's say to Columbia, and then the requirements for majors at Reed, the ones that overlap the most, where you sort of get double use of each class that you take, are physics, as Alison said, and math works pretty well too. We do have a computer science program now at Reed, and that one would work pretty well.
What GPA is required for Columbia? Do we know that?
Yes, it's 3.3 for your overall GPA, and also 3.3 for those special classes that you're taking for that are sort of like the STEM classes for admission to Columbia. And then you also have to get at least a B in every one of those classes, your first chance at it.
Ribby, you've now done this program. You're in your 3rd year. As you reflect on your Reed experience and what you did here, if you had to think about 2 things in particular, skills or things you developed at Reed that you draw upon?
The first one you learn is how to communicate with your peers and professors, I think. Reed's community is pretty tight, and you'll be learning all your professors on a first name basis. You'll see them almost every day. I mean, if you're in the physics department, you go down the hallway multiple times during the day. And you'll see your professor's doors open all the time. And learning how to communicate with the professors for research, academics, and maybe some personal life is important, especially in grad school, where the dynamics kind of change, because now your PI, your principal investigator, is kind of your boss. So you'll have to learn how to communicate your work, but also like you can still get close to your PI as a person. So you gotta do that work balance. The second part would be coding and mathematics. You get really good at derivations.
Yeah.
You get really good at derivations. Not to say that derivations in engineering are not hard, but you can really follow it easily if you graduated with a physics degree.
What path would you recommend for biomedical engineering?
Well, we do have a student currently who's interested in that. And so it would seem like biology would be the right one, but actually, there's lots of physics and math courses that are required for Columbia's admissions that aren't required for biology majors. So it's still, I mean, we do have, students, at least on theses, working on sort of biophysics related topics. So there's also the possibility of ad hoc majors at Reed. So you might be able to cobble together your own sort of biophysics type program where you would take more biology than physics majors usually take, and would, prepare you for biomedical research at Columbia.
For biomedical, one way to explore that path here at Reed would be to explore summer internships, and particularly with links to OHSU, which is the Oregon Health and Science University, which is just across the river, and is really graduate focused because it's basically medical school, but has lots of medical research. And there would be people to ask for summer internships if one were interested in biomedical engineering, to try to get the taste for it before heading forth into either 3-2 or other postgraduate biomedical engineering program.
Can you all talk a little bit about internships, students making those selections while they're a student here, how those happen? Should people be nervous about their ability to get internships and some of these research opportunities to help set them up?
The National Science Foundation has a program called REU, Research Experience for Undergraduates, and big research universities will apply for those grants and then have several of their professors have summer internships for students who apply. And we write a lot of letters and have a lot of success at getting our students into those programs for summer internships. And I agree with Alison that if you're really interested in engineering, those are great opportunities in the summer to apply instead of to physics related REUs, do engineering related ones, so that you can get your feet wet and see what engineering is really about before you transfer to Columbia, or let's say decide to go through Reed and get a degree here and then go to engineering graduate school later.
I'm going to ask two more quick questions: astrophysics, chemistry, a chemistry heavy field like environmental science, chemical engineering. Are there available paths towards those degrees, and what does that look like?
So for astrophysics, you'd probably want to be a physics major here. There's astro classes to take, and then could look for physics PhD programs with astronomy specialties, or there are standalone astrophysics PhD programs. But I'd say those are probably outside the fold of engineering for the most part. There are positions within astrophysics departments that are more instrumentation based, that you are really building the telescope itself or the instruments that you hook up to the telescope to record the observations. And so if you're interested in that side of astrophysics, it could still be an astrophysics PhD program. But then there's also like aerospace engineering, and so there's also programs that are more the engineering side, aerospace engineering, that you would go to engineering grad school for. And there's even schools that kind of focus, like Embry and Riddle, on that specific type of engineering to look into going to.
I'm going to ask a question. Anyone can answer this. So why do this at a liberal arts school?
It can make you a better engineer, because right, what Ribby was saying about you will learn to communicate here, that is super important in engineering, because a lot of engineering work is done in teams, and you need to be able to clearly communicate with your team of people who are trying to complete some task, right? And so I think particularly that the sort of learning how to be a good conference participant. And when I say conference here, that's starting from that intro humanities course that everyone is in. Everyone would be in a small breakout session of about 15 students, one professor, who dive into the text and discuss together. And to be able to learn how to have that back and forth in a productive fashion, I think is something that you don't get at a big engineering school. right? That learning how to communicate with your peers and with a professor in a really involved fashion. So I think that's something special about Reed. And I also think that the sort of writing side, so still communication, but the written communication, and this is a little bit taking it from my sister, who's now sort of using her engineering PhD in more of a consulting role, right? A lot of her work is writing. And when that, at Reed, you will also take a number of humanities courses that involve a fair bit of writing, and becoming really comfortable and clear in your writing is super important, because it's also very important to an engineer, and it's not necessarily something that's taught in the same involved manner at a big engineering school.
Mm-hmm.
So those are two things, and maybe not the only ones.
When I was going into Reed, I knew I was going to grad school after Reed, so I was using Reed as a stepping stone. So I thought a lot about which college I would go to with my father, and I do strongly believe this. I feel like for college, you should go for a really small one. A small one as in you can take a lot of the classes you want. It's not that they're easy. They're going to be hard, but you're going to get the most out of it. And the professors are really dedicated into teaching. So they don't have like the half and half research and teaching where big universities like my current graduate school has. So you learn everything you can in a college, and then you can use the fundamentals you've gained to go to grad school and go into a specialized area.
Yes, I completely agree with what Alison and Ribby are saying, but I did want to say that Reed's very supportive of the sciences, and so we have very well outfitted labs and up-to-date equipment. So you do get technical training here, like you would if you went directly to just an engineering school.
I was just going to add in, it's fun. I mean, like it's really nice to take classes that I think I decided to take religion classes for my group A requirements, which is like English and arts maybe, or religion fulfills one of those. And it just is exciting to think about something totally different than what you normally study. And in weird ways, there ends up being crossover or new perspectives you gain about either this class that feels really unrelated or your own major. I took a religion class on Jewish mysticism, and a lot of Jewish mysticism is like, what are the origins of the universe? How was the universe created? And my professor was also really interested in, does this have any relation to physics? Like, is there anything we can read from these texts that might, and like, so we had all these interesting discussions in class. And like, I didn't, even signing up for the class, I had no idea that, those kind of weird connections were going to pop up. So yeah, it's definitely just, fun and exciting to take all these other classes that you might not think are like relevant to your major degree.